I wanted to make a quick bonus video about why I choose to index starting at a sub 0. You could, if you wanted to, index this differently. You could index this saying that the first term is actually just going to be a sub 1. So the second term will be a sub 2, third term will be a sub 3, fourth term will be a sub 4, and so on. And that is totally fine. You just have to retitle this a sub 1 since that's your first term. But it gets really tricky here. Not even really tricky, just more annoying, less clear. Because if I am trying to use this same idea to define it, well, let's test this out. If I plug in 2, or let's even find the first term. Like, does this work for the first term? So if I plug in for the first term, a sub 1 would then be 11 plus 3 times 1, which is 3, which is equal to 14. Okay, so instead of getting the first term, I accidentally got the second term. It's fixable. What you do is you take k minus 1. And so that means, like, I'll plug in whatever number of 3s I've gone, but have to subtract away the first term because it's already there. So this is true. Then I take a sub 1 equals 11 plus 3 times 1 minus 1, which is 3 times 0, which is 11 all by itself. So this works, but there are 2 reasons I don't like it. One is, this is harder to understand what is happening, in my view. Understanding that this is we know at our core this is a plus 3 sequence. This doesn't look as clearly like a plus 3 a certain number of times sequence. It looks almost like a weird algebraic, I don't even know. But I'm just less able to see the meaning in it. That's part 1. Part 2 is most computer programming languages, and you know that I am a nerd for this stuff, most computer programming languages index starting at 0 anyway. So a sub 0 is the first term, a sub 1 is the second, a sub 2, a sub 3. And to the extent that I can let math be a gateway to understanding other things better, I want it to be. And so that's why when I teach this and when I think about this, I index starting at 0, not at 1.